We're going to talk about the fundamental counting principle now and show how we use it. And the idea here is if you have several selections, several decisions, or several things that you're picking, and each decision or item that you're picking has has a specific number of choices itself, and it's the number of choices that matters, not particularly the given choice. But as long as the number is the same, so if our decision tree, when it splits, it could only split twice, but at the second level it splits 3 ways, then this is okay because we have 3 decisions to make whether I go this way or this way. If this is the case, then we can use the fundamental counting principle to find out how many selections there are, how many choices we could have. So here's the definition. If a first choice can be made in P different ways, a second choice can be made in Q different ways, a third choice can be made in R different ways, and so on, then the sequence of choices can be made in P times Q times R different ways. So we just simply multiply the number of choices for each choice that we have to make, and that tells us how many different ways we can do. So here's an example. Suppose that Reba gets to choose both dinner and a movie for a Saturday night date. She can choose from any of 7 restaurants and 5 movies. So she has 2 choices. Choice 1 is the dinner, where she has 7 options. And choice number 2 is the movie, where she has a choice of 5 options. There are 5 movies that she can see. Well, choice number 1 has 7, and we're going to times that by choice number 2, 5, which tells us that there are 35 different combinations of dinner and a movie that she has available to her. Similarly, suppose we have a 4-digit number, and the question is, how many 4-digit numbers can be formed with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 if the first digit cannot be a 0? So we have 4 different digits, but they have some different choices. So this is the first one. Then we have a second, a third, and a fourth. And I'll use O for fourth. So the first one cannot be a 0, so it can't be this. But that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9 different choices. So there's 9 different ways for the first one. The second one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The third one has 10 as well, because nothing changes. And the fourth one has 10 as well. So we end up with 9 times 10 times 10 times 10, which is 9,000. There are 9,000 different 4-digit numbers that can be made from these digits, so long as the first one cannot be a 0. And so this is how we use the fundamental counting principle. If the number of choices doesn't matter, if they don't depend on each other, there's no other things that we're doing to count the number of choices we have, we just multiply the results from each one.